Imagine a comet so bizarre, it's leaving scientists stunned and eager for more information. The interstellar comet 3I Atlas has been making headlines, and for good reason. Its unusual behavior is challenging our current understanding of these celestial bodies. But here's where it gets fascinating. 4 powerful telescopes, including NASA and ESA instruments Hubble, SPHEREx, JWST, and TESS, have all observed the comet, revealing a plethora of intriguing details. One of the most striking aspects of 3I Atlas is its atmosphere, or coma, which contains a higher proportion of carbon dioxide than typically seen in comets. This could be a clue to the comet's origins, the environment in which it formed, or even its internal composition. The comet's story begins on July 1, 2025, when it first caught the attention of astronomers. Since then, scientists have been racing against time to gather as much data as possible before the comet's closest approach to the Sun, or perihelion, on October 29th. A challenge is that the comet will be hidden behind the Sun's glare, making it impossible to observe from Earth. To make the most of this limited window, researchers are using some of the most powerful instruments at their disposal to study the comet. And this is the part most people miss. The comet was already active when it was first spotted, with its ices subliming, transitioning directly from a frozen to a gaseous state, at a distance of around 6 astronomical units AU from the Sun. This is much farther away from the Sun than expected, as most comets don't begin to show activity until they're within 5 AU of the Sun. The TESS data suggests that the comet's early awakening may be related to its composition, with some ices subliming more readily than others. Carbon dioxide is one such ice, and its presence in the comet's coma has been confirmed by 2 separate measurements using different instruments. In mid-August 2025, SPHEREx took multispectral observations of the comet, resolving a coma rich in carbon dioxide and water. The JWST also observed the comet, finding a ratio of carbon dioxide to water of 8:1, one of the highest proportions of carbon dioxide ever seen in a comet. But here's the controversy. What does this mean for our understanding of the comet's origins and composition? Some scientists suggest that the comet may have formed close to the CO2 ice line in its parent protoplanetary disk, or that it contains ices exposed to higher levels of radiation than solar system comets. Others propose that the low abundance of water gas in the coma could be due to inhibited heat penetration into the nucleus, suppressing the sublimation rate of water relative to carbon dioxide. As we continue to study 3I Atlas, we may uncover even more surprises. The comet's trajectory will take it behind the Sun, but it may be close enough to Mars for orbiters to catch a glimpse at perihelion. After perihelion, the comet will make its closest approach to Earth, and in theory, Juno could even intercept it when it whizzes past Jupiter in March next year. The findings from Hubble, TESS, SPHEREx, and JWST are available on the preprint server archive, and we can't wait to see what else our intrepid astronomers will discover about this fascinating object. So, what do you think? What secrets do you think 3I Atlas still holds, and how will its study impact our understanding of the universe? Share your thoughts in the comments below.